Make sure. Okay, you got the recording on. Okay. So question for you is just straight up algebra.
Is it just 2? Or do I have to do the actual math for that?
The y-intercept, yeah, that would just be 2.
Okay.
Do you remember what they call it here?
So the B,
Because, yeah, in algebra, it was mx plus b. Remember what they call it here?
y-intercept is B0, which is the 2. So it's B0 plus B1x, and B1 is the slope.
Okay.
And then y hat, yeah, okay.
Yeah. And then, not that it matters, I don't know, I'm trying to think if you'll see it. Well, how many semesters are you from graduating? Don't you have like one semester left?
One more semester.
Okay. And you're not taking any additional math classes or chemistry or physics or anything. Then it probably doesn't matter, but just vocab. When you see a little 0 in front of something, that's referred to as the null. So that's why it's our null hypothesis is H0.
Oh.
And usually, if you see that, you refer to it as the not. So null hypothesis, yeah. So null hypothesis, we have a special name for it, but if it's another thing, you'd call it H naught. And so this would be referred to as B naught and B1.
Okay.
So just FYI.
B naught.
Yeah, and it's not as in N-A-U-G-H-T. So not meaning nothing, not meaning N-O-T.
Okay.
I doubt that's going to pop on a test. That is just a little FYI because, yeah, just hearing you say B0S, I was like, oh, that's weird. Like, I remember doing that like my first week in physics. My teacher was like saying X naught and Y naught. I'm like, what the heck are these things?
Like, what in the world?
What is the predicted value if X is equal to 16?
So slope is 1.5, right?
Yes.
And then is it 1?
Yes. You had to do that because I did it with Excel and it's like 1. And I thought, oh, wait, 16 divided by 4 is going to be 4. 4 minus 3 is 1.
Probably could have done that in my head, but
yeah. No, it was weird just seeing such a simple answer. We don't get simple answers in this class.
yeah. Let me scan that.
Scatter plot. Okay. We need to get quantitative inference. Okay.
So I got,
I would say hot dog shape.
yeah, for sure. Cool.
I would say simple linear regression is appropriate for this.
Yeah.
It's not like the cleanest data, but it definitely looks linear, and it looks like there's a correlation.
Yeah, there's a shape to it.
Observations in the data. $138.
How do you get that?
I was just going 142 minus 4. I feel like I might be doing something wrong. What you can do is go
Is it
equal
just
count and then highlight the cells that you want counted.
okay? And it would be both columns that we used, right?
I'm just doing one because one observation is going to give us two different variables.
Yeah, you're right.
Confidence and the score. So I'm figuring that, yeah, so you're getting two variables from each student. So I'm assuming that how many observations is more how many students were observed as opposed to how
Yeah.
many, yeah. So I got
139.
Yeah, that's what I got. The y-intercept, I got 1.296. One's under H13.
Um, H13. Oh, I see. Okay, sorry. That took me a second. 1.296.
Yeah.
Okay.
Yeah, no, this thing is hard to read until you kind of get a hang of it.
Yeah. What is this? Slope? Point
Slope.
042.
0.042. Yep, that's what I got. And then for this next one, it says the predicted value. So we wouldn't just use the equation like we did on question 5.
We would do p hat. I mean, sorry, p hat. Y hat.
So what we do is we go to G18, and that cell is highlighted blue, letting you know that it's an input variable. So we can actually change that number. So we take that and we change it to 4, and then right next door is predicted, and that gives us the predicted value.
So 1.462.
Yeah,
Okay.
because if we do, what's the equation? I'm kind of curious, but actually, okay. Well, I just want to see something real quick. So the 1.296 plus 0.042 times 4. Yeah, so if you do the math, if you just do the equation, it's 1.464.
Mm-hmm.
So if you just use algebra, it's going to be off by at least a little bit. So the Excel sheet does whatever it needs to do to make it more accurate. So make sure when you see, if question 5, like on question 5, if it says given the linear regression equation, what is the predicted value of y? And they haven't given you a bunch of values like they've given us on this one to stick into the linear regression spreadsheet.
Yeah.
Then you just do it like algebra. But
Okay.
if they have given you a huge freaking thing and they ask what is the predicted value of y, then make sure you use the spreadsheet because you're not going to be able to calculate it by hand.
Okay. Makes sense. So for 12, do we put in 6 for G18?
So the confidence data results in students valuing the confidence for each question on a scale of 1 to 6 with the maximum predicted value of y. Wait. Oh, so it's asking just for the maximum. I saw confidence, and for some reason I thought confidence interval, and I thought we're dealing with a range. If they're just dealing with the maximum predicted, yeah, we would just put in 6.
Okay. And then we would look at
Okay.
are we looking at the confidence interval? The confidence data?
What is the maximum predicted value of y? So we would just look at the predicted again.
Oh, okay, so it'd be 1.546.
Yeah.
Is it 2 for 13?
Walk me through your reasoning.
So independent variables, so I was just assuming, we copy and pasted column 1 and column 2. Those are variables.
Look at column 1 and column 2. So look at, column A and column B. What does it say in cells 2 and 3? I guess specifically cell 2, so A2 and B2.
Explanatory and response.
So explanatory is the independent, which is what we're measuring, and then the response variable is what we're saying occurs because of our explanatory. So
it's one variable.
Yes. So this example, it's a little hard because they're kind of going abstract with a student's confidence versus their score.
Mm-hmm.
But an explanatory variable would be something like the amount of sunlight a plant receives,
Mm-hmm.
and then the response variable. So the explanatory, which is independent, is what we control, and that would be like the amount of sunlight a plant receives.
Mm-hmm.
Then the response variable, also known as the dependent variable, it's dependent on the independent variable, would be like the height of the plant. Because we're assuming that the more sunlight a plant gets, the better it's going to grow, so that's the taller it will be. And so that's saying that the height of the plant is dependent on the sunlight, or in other words, the dependent variable is dependent on the independent variable.
That makes sense. Okay, so then the dependent variables would be just one as well.
Yeah.
Okay.
Oh. I read axes as axis. I was like, what the heck do hats have to do with axes?
Uh-huh.
So let's predict the size of a hat given the circumference. So what's the answer you got?
That's a good question.
This is again kind of another tricky one that they're given.
Yeah, so the measures of collect include hat size.
Think about it this way. So they're recording measurements on all hats. What if instead they were looking, because taller people tend to be just bigger proportionally in all dimensions.
Mm-hmm.
So you would assume that a taller person would have to have a bigger hat. So what if you were checking hat sizes based on the height of an individual? Which one would be the independent? Which one would be the dependent variable in that? Or what would be the explanatory? Which one would be the response?
The dependent or the response would be the height.
You sure?
Because we're measuring hat. Oh, okay, wait.
So what are we measuring and what are we predicting?
So, or measuring, in that example, would be measuring the height and the size of the hat. But we're predicting that the bigger hat will be for someone taller.
Yes. So if you have this data that tells you taller people tend to wear bigger hats, and you have someone you're like, okay, someone who's 6'3" is coming in next week. What size of hat are we going to have to get him? So in that case, the hat would be predictive. We'd be predicting the hat.
Okay.
So in this case, they're recording the measurements for the circumference of the hat, and then they're trying to figure out, okay, so we take the circumference of the hat. That means when you take circumference, which is 2 pi r, so it's not a direct relation because there's pi in there, and then you have to take into account that it's half of a sphere, so you have to figure out the amount of material that you have to make. So they're trying to basically estimate how big are these hats going to be based on the circumference size that they need to be.
So is it the size of the hat because it is the variable being predicted?
Exactly.
Okay. It was simple, but kind of weird.
Just used a weird example there.
Okay.
Oh, ouch.
Oh, what?
Missed 4.
Really?
Yeah, and they're all in a row. It was 9, 10, 11, and 12. So we did something wrong with that one, since it's all involved with the one with the math efficacy.
Okay.
And I think, let's see. Let me pull that up again. Okay, yeah, so 139. Make sure there's not any spillover. Yeah. And double checking. So make sure I didn't type something wrong. What did you get for number 9?
So I got 1.296.
Okay, that's what I got. What if... Go format cells. Decimal place is 4. So 1.2955, so that one would be 1.296, 0.0417, so that'd be 0.042. Huh. So the y-intercept and the slope. Yeah, that's definitely the right things.
This is weird.
Let's see. Maybe, I'm not sure if it'd make a difference, but Let's see. Oh, I think that's it.
What was it?
Let me double check. Yeah, I just copy and pasted the two columns.
So did I.
It turns out confidence was supposed to be the X variable.
Oh, does that make a difference?
And the score is the response variable. That's what I'm going to check real quick to see if it makes a difference. Yeah, I just copy and pasted both at the same time, but it looks like, let's see what happens when we switch them. Okay, close that. Open the file again. I misplaced one of the numbers, so I've got to find the file again. Okay.
So my numbers are super different.
Okay, then that's probably what it was.
Okay.
Hold on a second. Let me double check.
So I can switch this and submit it and see what happens.
Okay. Yeah, I got a new y-intercept of 18.690 and a slope of 12.695.
Yep, that's what I got.
Okay. And have you submitted?
Not yet. So we got 11 wrong too, right?
We got 9, 10, 11, and 12.
Okay, so
But that's because they're all based off of us missing the two, swapping the two columns.
yeah. So let me switch this to 4. So the predicted will be
value. We put in 4.
69.469.
I did something that made Excel sheet not happy. It's giving me a predicted of 0 regardless of what the X is. I'm going to close out of the quantitative inference and open up a new sheet.
Oh, cool. Oops, I think I submitted too soon. So I got 9, 10, and 11 right.
Okay. So it was just swapping the two.
Yep.
Okay. Then I'll just go back through and fix that on my end.
But 12, I didn't change 12, I don't think. That was my fault. I got a little too trigger happy. So we
Okay. Well, that one would just be change where you put x equals 4 to x equals 6.
And then it would be 90. Okay. Okay, cool.
Okay.
But yeah,
so I'll go fix that. Okay. Before you go, this is me being a dork. I'm going to screen share real quick so you can see this.
Okay.
I'm so proud of myself. I'm an idiot for being proud of myself. But okay. You're seeing my screen, right?
Yep.
Usually it does. Oh, usually it does like an infinite loop. So that's what I was waiting for, but that's not what it's doing. Okay. So Putty, program that we work with. This is old school. This is
yeah, this looks old school.
yeah. Nowadays everything has what's referred to as a GUI, a graphics user interface. This was before graphical user interfaces, and so this is just console interface. You don't have fancy graphics to click on like over here. Everything is text based. So we start with, I gotta check this real quick. So open test.txt. Okay, that's empty. Good. And then if we go 12.txt, oops, open 12.txt. So here's the Sudoku grid right now.
Mm-hmm.
If we open up my program, which I'm working on, so I just called it progress. So file progress and open it. It says, where is your board located? 12.txt. Then it shows the options that you have, and then it also shows the Sudoku grid. And seriously, like you wouldn't think it, but just putting in this here, these spaces in here, and this took me forever, was getting the row number followed by spaces. Took me so long. So now that we're here, I've gotten this done, and this done, and this done. I'm still working on these two steps. But if you type in D, then it displays the Sudoku. If you go question mark, gives you the instructions again.
Huh.
Question mark, gives you the instructions, display. And I specifically made it, you can see that the lowercase d or even an uppercase d will display. And then you hit Q to quit, and it asks what file do you want to save it to. Test.txt. It quits out, and we go open test.txt, and there's the grid.
Holy
That took me so freaking long to do, but I'm so proud of it. Because look at this code. This code is ridiculous. So going all the way.
And you had to type all that out?
Yes.
You serious?
And so these are the 3 steps that I'm working on right now. But
that's insane.
This is what, just to put the numbers within the grid of like AI and stuff. So Calc basically says print to screen. So print to screen the first row, which is simple enough because the row's by itself. But then after that, it got really messy because I had to take into account whether I needed like hyphens or plus signs, or there's vertical bars or spaces or new lines. So essentially this says, go through the entire grid by row and by column.
Mm-hmm.
If the column is equal to 0, then put down the row number +1, because row is starting at 0, but on the grid it shows 1 through 9. So print row +1, then a space, then give the value of row 0, row whatever the number, 1 through 9, whatever it is, and then column 0, and then add another space. If it is not column 0, if the column does not equal 0, then what you want to do is you want to put down the value from the Sudoku grid. And if you divide the column by 9 and get remainder 8, then if that's true, put a new line. If it's false, then check to see if it's divisible by 2 or 5. If it's divisible by 2 or 5, put a vertical bar. If none of those things are true, then add a space at the end. That took me all last night to figure out.
Yeah, it's insane.
The display options was nice and easy. Display options is just print out the different options, and that was it. All of the dash n just means new line, so that way you get a nice, rather than a long string, it's options, new line, here it is, new line. So that was blessed. This one is where you actually take into account what someone is choosing. So you have their input. Sin means that you take in their input. So C out is console out, C in is console in. You take their input, and then switch is basically a bunch of if-then statements. So case question mark, if it's a question mark, display options. If it's D, then display board. I haven't gotten to get coordinates yet, but E would be edit. S is, this is where it's going to get weird. I'll show you this in a second. And then Q for break. And then this up here, to upper, that means whether you put in a capital D or a lowercase d, it's going to uppercase it anyway. So that way it's going to register no matter what. And then down here it says basically cycle through this list of commands until the input is either a capital Q or a lower Q, in which case it'll ask you to save, and then you can exit out. And then here's the actual reading and saving of the documents. This took me forever. So basically open the file, if stream, put in file, well, you have to ask for the file name first. So string file name, print to the screen, where is your board located, accept the file name, then return the file name. Then the file name gets returned and can be used by the function up here, at which point you go if stream thin, which is a fancy way of saying open this file name. If it fails to open, print out a message that says we could not open file name, new line. If it does open, go through by row and column one by one and read the data, and then set the data that you've read to the board, and then close the document. And then kind of just the reverse for the saving the document. What file would you like to write the board to? The document name called save document, and then it's just kind of the reverse of what we did up there. But yeah, that's what I've been working on for the Sudoku, and you can see, yeah, it's a huge mess of lines, and it's taken me forever, but I'm so proud of it.
Yeah.
Like, holy crap.
That's insane, honestly.
This is the killer thing that we need to work on, and I'm not excited about this for next week, but I think it'll be challenging and fun.
Mm-hmm.
But what we got to do is, okay, I got to switch classes. So computer science. So this week I've pretty much got it done. I've got a little more that I need to do. Like, for example, I have to figure out how to get rid of all the zeros, because you don't have zeros on a Sudoku board. They're just blank, or they're numbers 1 through 9, you know?
Yeah.
So I've got to figure that out. But this is what we're doing for this week. So read, I've got down. Write, I've got down. Display, I've got down. Edit square. That's what I'm working on right now, and I need to have that done for Saturday. And then I've got quit and display options. This is what we're doing next week, and this is insane. I'm trying to figure out how we're going to do this. Oh, my teacher words it weird here. It says, so let's see, enforce the rules of Sudoku. So that means the things that I haven't gotten to is you need to be able to not only edit a square, but someone needs to be able, so we have get coordinates, and get coordinates goes to two different things. It goes to edit square, where you can change the value, hence otherwise it wouldn't be Sudoku, there would be a way to solve it.
Yeah.
But then we also have to do is